Thank you very much, Professor Fair, and hello, everybody. I feel very much at home here, even though this is not my own university, because universities have their own culture. They are ancient institutions. In the case of University of Zurich, I'm not sure whether it's the 1830s or the 1530s that you would date yourself from. Yale dates itself from 1703. These are institutions that have long horizons. They invest in students in their late teens and early 20s who will live and be productive and influential citizens of their country and their world for decades to come. And therefore, no topic could be more appropriate for this organization and this meeting than climate change. Now, okay, challenge one, met. This picture demonstrates in a very graphic way that the threat of climate change. This is a picture from the Prado of the Colossus by Goya, and you should study this. You probably can't see. Can you hear in the back? Can you hear in the back? Okay. You probably can't see this if you're in the back, but you can look it up. And what it is, this is the population fleeing in a great migration from a very great threat that's facing that culture many, many years ago. But we're facing another one today, and let's talk about that. Now, okay, somewhere here. So I have four major points I would like to make today. The first one is I'd like to talk a little bit about the science, because there are still some people, maybe not in this room and maybe not even in this country, or maybe only one in this country, who claim that there is no wolf, that there is no wolf. Then I'd like to talk about the landscape of carbon pricing, which is one of the instruments that have been proposed by economists. Then I'll talk about current approaches to climate change, such as the Kyoto Protocol and the Paris Accord. And what I will suggest is that these turn out to be a dead end because of the structure in which they're organized. And I'll end with a discussion of something I call a climate club, which is a different way of organizing climate treaties that may be more effective. Now, let me start with some scientific background. Many of you know a great deal about this, some of you much more than I do, but it's always useful to look at the latest information that we have on what is happening with our climate problem. So let me begin the first slide, which shows global CO2 emissions. I'm going to focus today only on carbon dioxide, which is the most important, but not the only one, but one that is very well studied. And this shows you data on global CO2 emissions from 1900 to 2018. And it's on a ratio scale, so a straight line there is a constant growth rate. So what you see is a trend over this period now of more than 100 years of growing CO2 emissions more than 2.5% a year. And if you look at the very end, if you could see this, you see they've flattened a bit since the 1970s, but they continue to grow. A better way to look at the CO2 emissions is what is known as the carbon intensity. And this is the ratio of carbon dioxide emissions to output, and this is at a global scale. And what this shows is, in a way, a hopeful slide, because the green wavy line there shows the trend over time in the carbon output ratio, and it shows that the global economy is decarbonizing, meaning less carbon per unit of output. It's decarbonizing over this period from 1970 till 2018 at about 1.5% per year. And there's a little bit of a sharper decline in the last decade, but as you'll see in a minute, it's still basically a steady trend at about 1.5% a year. So one of the messages I'd like to get across today is that even though we have taken steps in the international arena and in the EU and some of our countries, we've not taken nearly enough steps to reach the targets of our international policy. Now, let me say a little bit about global temperatures. There's been the first slide I'll show you is a reconstruction of global temperatures done by a earth scientist, Michael Mann of the Pennsylvania State University. And what he did is, we don't have instrumental records back this far, but what he did was construct a proxy records on the basis of various observations, such as you may know about tree rings, boreholes, some from ice cores as well. And this is his best reconstruction from about 500 of the modern era to 1950 of global temperature. And as you can see, there's a lot of variability in that. But what I want to show is I want to superimpose upon that the observational data to see what's happened. And you can see that in the last, since 1950, you can see what's happened is completely unprecedented. So if I just showed you this line, the blue line and the red line, and I said, do you think there's been a change in trend from the blue line to the red line? I think it would be very hard to say, oh no, there hasn't. I think you can see I think in a way this is the most dramatic evidence I know of the actual trends in global temperature. Final science slide is to ask about actual and aspirational emissions. So this slide shows on the left from 2000 to 2019 the actual emissions of CO2, global emissions. And then it shows three lines, one in, let's say, coal black, which is the business as usual or the trend. That's often known in the technical parlance as a base estimate. That's to say, if we continue the kinds of policies we've had over the last few decades. The one in the middle is the emissions that is consistent with the Paris Accord, which is the current international agreement, and the Paris Accord assuming that all countries meet their commitments, and that it continues on a downtrend up through 2100. And then the aspirational green line shows you what emissions would have to be to meet the 2-degree target. And the very sobering fact is, according to all the models that have looked at this, is that you'd have to have very, very sharp declines in emissions, hitting net zero somewhere around 2040 or 2050, depending on the estimate, if you're going to meet the 2-degree target. So where are we actually? Well, we're actually so far on the black line. We are probably not going to meet the Paris emissions targets because some countries like the United States, well, the United States being the one country that stepped out of it so far, and other countries are not necessarily meeting their targets. So this is really the key, one of the key points I'd like to make tonight, which is the international agreements, even if they are met, the Paris Accord, even if it is met, even if countries meet their commitment, the Paris Accord is nowhere near meeting the emissions target we'd have to meet our 2-degree goal. You might, with the Paris Accord, hit a 3-degree or 4-degree goal, but you're definitely not going to hit the 2-degree target. And I won't even go beyond that to talk about 1.5 degrees, which is less than 2 degrees. All right. Now, so much for science for now. Let me turn next to the view of economics. So I'm an economist, so why are economists talking about science, climate change? Why are economists talking about carbon dioxide and other greenhouse gases? So that's the question. What are the key economic insights? One of the key ones, I'll skip over many of the others, is that an effective international policy is one that needs to raise the price of carbon or carbon dioxide emissions through a carbon tax or cap and trade or other mechanism, and it needs to do it in a harmonized way around the world. Now that's an ideal, but it's such a clear ideal, it's so easy to understand that you have to have the same carbon price in every sector, in every country, if you're going to have efficient emissions reductions. I don't know of any question to which the answer is so simple as what is the efficient climate policy. It's harmonized carbon prices around the world. Now, it's not only efficiency, but it is actually the key to getting sharp emissions reductions. We need, if you think about it, who are the culprits here? Who are the guilty ones? You and me and everybody. We're talking about billions of people, thousands of governments, millions of firms, hundreds of countries, maybe not all of them equally important, but those are the people who have to make the decisions. Those are the institutions and the people who have to make the decisions if we're going to control CO2 emissions and therefore slow climate change. And how are you going to reach people? You're not going to reach people by sermonizing because they don't speak the same language and they don't have the same religions. The way you're going to reach them is through the pocketbook, and it's by making the price of emitting carbon dioxide expensive. And that is what we mean by a carbon price. Now, there are different ways of doing it. The one that has been most popular, the one that has been most used up to now is a cap and trade program, such as it is used in the European trading system and in several countries around the world. But an alternative is a carbon tax, much simpler, but not so popular among governments and people, where you just put a price on it. Cap and trade is one where you cap and then you allow the owners of these permits to trade them, and that will set a market price. Both of them will do the trick of setting a carbon price. And as far as we know, those are the only two. They're the only two mechanisms we know for having a carbon price, are either putting a tax on emissions or having a cap and trade system such as the European trading system. Now, one of the key points of efficiency is to have regions harmonize their carbon prices. You don't want carbon prices low in one region and high in another. For one reason, you want to have, you don't want countries or regions with low carbon prices producing carbon-intensive goods and exporting them into the other region. And also, the first units of carbon reduction are actually quite inexpensive. You could probably reduce 10 or 20 or maybe 30% at virtually no cost. But it doesn't make any sense, therefore, to have some countries do 0 and other countries do 60%, where you could get it for much cheaper if everyone does 30%. Now, the final point about the economics here is the level of the price needs to be set to meet your climate target. So if your climate target is a high one, maybe you're not very ambitious and you say, oh, I'll just be happy to even hit 4 degrees or 3 degrees, then you have a lower carbon price. But if you're going to try to contain it at 2 degrees C or 1.5 degrees C maximum, then you're going to have a much higher carbon price. So for less ambitious targets, you might have a carbon price of $40 or $50 a ton. But if you want a 2-degree target, you're going to probably have one in the hundreds of dollars a ton. And not $100 a ton in a few years or a few decades or a few centuries, but right now, or at least not today, but tomorrow. So what is the landscape on carbon pricing now? Well, the landscape is like Switzerland. It's a lot of ups and downs. some warm places, some cold places, some places where nobody lives, some places where nothing is being done, some places where much is being done. If you look around the world, there's a very good report that's produced by the World Bank on carbon pricing, and there was one just for 2019. And what you can see is that many, many countries are developing either cap and trade programs, like the European trading system, or carbon taxes, which actually prices on carbon emissions. Maybe 60 different jurisdictions around the world. China has a new national one. Canada has one of the most complicated ones. Korea has a teeny little one. Switzerland has one, I'm told, although I haven't studied it carefully. But like Switzerland, well, no, let's leave Switzerland out now. The policies are highly fragmented and weak and inconsistent. So, for example, I'll show you in a minute what the numbers look like, but some countries have nothing. Some countries have very high prices. In countries that have high prices, some sectors are exempted and some sectors are priced very high. Typically, transportation, gasoline, and automobiles or motor fuels has a very high carbon price, and typically tradable goods have no carbon price. In addition to that, there are subsidies around the world, and the subsidies are actually larger by almost an order of magnitude than the taxes. So we have many countries that subsidize fossil fuels, they subsidize heating fuel, they subsidize gasoline, and once you start down that road, it's very, very hard to get rid of your subsidies because your government's likely to be thrown out of office. So you have to think not just carbon prices, but also reducing the carbon subsidies. Now, as I mentioned a minute ago, you might say, what are the appropriate carbon prices if we could live in the ideal world where we had harmonized carbon prices? What would the price be? Well, at the low end, the calculations that were produced by many countries are in the $40 per ton of CO2 range. But as I mentioned, if you want to get a more ambitious target, you're talking about in the hundreds of dollars, maybe $200 a ton range, and rising sharply if, say, you wanted to meet the 2-degree target. What is the actual? So let's say the ideal number is between 40 and 200. So let's just agree that that's the range, or just stipulate for the moment that's the range. Where are they now? They're less than $2 a ton. If you actually look, what are the actual prices on the ground in different countries? They're about $2. Okay, so where? If you can read this, which you might in the front but not the back, I'll tell you what it says. So the highest tax country is Sweden. They have a carbon price in Sweden of $127 a ton, but it only covers 40% of the economy, and the actual effective price is therefore about 51 cents a ton. Let's go down to line 3. Switzerland, which according to the World Bank, I can't attest to this is World Bank, has a carbon price of $96 a ton. That would be, I guess, 80 or so euros a ton, or no, Swiss francs, I'm sorry. 90 Swiss francs a ton, something like that. But it only covers a third of Switzerland, basically motor fuels. So the effective carbon tax rate in Switzerland is $32 a ton. Well, let's go down to the bottom line. The bottom line here is that the bottom line says, if we can see it here, 80% of the world. So anyway, these carbon policies, which range from a high of $50 in Sweden to 50 cents in Mexico, cover 20% of the world. And 80% of the world has zero. So if you add those all up, that's $1.70, roughly a little under 2 Swiss francs per ton of CO2 is the actual carbon price. So the reason I say that is, well, 2 reasons. One is, let's just be realistic about what we're actually doing now. We're actually doing very little. If you're modest in your aspirations and you'd like a $40 a ton which is a nice place to start. You're a 20th of the way. If you want to go to $200 a ton, you're less than 1% of the way. So let's be realistic. Not only that, but these are, as you can see, highly fragmented and very different and not harmonized. I don't know if this picture is effective or not. Oops. But this is a picture that shows, it's a cumulative diagram that shows what the prices are as a percent of emissions. What we'd like here is a line where everybody's at $40. So you'd have a horizontal line at $40 or maybe $200 up in the next floor. But actually what we have is a this shows you, these are a very small fraction of the world. Like 10% of the world has more than $10 a ton, and all these other people are just nothing. They're just nothing. Okay. So again, this is the global average price, $1.70 a ton. And that's without leakage. This is a technical point, but some of you, just for a little geek moment, if I might. So if you have leakage, you have some high price. So the average is actually $1.70. But if you realize if you have different prices, then you're going to have leakage because the high CO2 industries will move toward the low tax. So if you take into account leakage, it's more like 40 cents a ton. All right. All right. So that's the landscape on carbon pricing. And what it says is that like many governments around the world are doing things. Yes, they're like covering 20%, well, many, covers 20% of emissions, global emissions. But they're not doing very much. They're using different plans. I haven't even talked about the fact that the plans are very different. Some are carbon taxes, some are cap and trade, some are mixtures, some have caps, some have floors. So it's unharmonized both economically and structurally. Okay, so what's going on here? The point I'd like to end with tonight is that international climate policy is at a dead end. That's what that slide says. Okay. International climate policy is at a dead end. And why is it a dead end? It's a common occurrence where you have this kind of structure and it's known as the free rider problem. Okay, what is the free rider problem? And what is the free rider problem? The free rider problem is, if you can, you ride free. And I always think of the Zurich trolley. And every time I get on the Zurich trolley, I don't have a pass. Maybe many of you probably have passes, so you don't face this dilemma every time you get on. Are there passes? Yes. Okay. Does anyone have a pass? Okay, everybody's pass. Okay, so you don't face this dilemma. And every time I get on, I say, well, I haven't got my ticket, I didn't buy it, I forgot to buy it, I don't have any change, my credit card doesn't work, and so on. So I can think of all the reasons. And then I do a quick cost-benefit analysis, and I say, okay, it's going to cost me 10 minutes of time and whatever it is, 8 francs, to get the ticket. And if I don't have a ticket, then, what do you call it, Ride Schwartz or something like that? And is that the term? No? Okay. Schwartz? Anyway, Schwarzfahren? Okay. So then someone will come around and say, may I see your ticket? And I'll say, oh, I don't speak German or something. You know, like, I don't speak your German. I'm sorry. And then we'll go through that little paradigm, and always we'll go through the little thing, and then always the cost-benefit analysis says, don't pay, don't buy the ticket, because the chances are very, very slim, and the penalties are not that great. So that is the syndrome that leads to free riding, where you have a choice of whether to contribute or not, and it's actually cheaper not to contribute. Another way to think of it actually is, let's assume that there were here's the nature of the international climate treaties. It's a voluntary fare. So you're asked to contribute 5 francs, but you don't have to, okay? But, it's a worthwhile thing, and we need to pay for the trolley, we need to pay for the conductors, we need to have upkeep, there's electricity and so on. So we ask you, please contribute, and so you will make a commitment, each of you will make a commitment that you're going to pay 5 francs every time you ride the trolley. Well, but there's no reason to pay because there's no enforcement mechanism and there's no penalty if you don't. Well, that's exactly what the problem with the international climate treaties are. And what we've seen after 30 years, actually 33 years since the first binding international treaty in climate, which was the Kyoto Protocol, 1997. The Paris Accord, the Copenhagen Accord, is that we actually have no binding international agreement that is coming close to meeting what we need for our aspirational or even reasonable targets. We have $1.7 per ton of CO2 emissions effective charge. And that's why I say these are a dead end. And the reason they're a dead end is because they are hampered by free riding. The agreements are voluntary, and there are no penalties for non-participation. Even nothing other than a slap on the wrist. So that's the free rider problem. Now, what are some examples of free rider problem? Well, I gave the one of the Zurich trolley, but there are other interesting ones I'll show you. One is NATO. So American presidents always complain about free riding in NATO. They say, we pay all the dollars, we pay all the costs, and we're protecting you all. This goes back a long way. This is not modern. This goes back, I think back to Kennedy, but I'm not sure. That would be 1960. So here's a little picture that shows you free riding in NATO. Okay. And on the, I've shown this before, but only with red dots, all right? But the horizontal axis here is gross domestic product in billions, but it's on a ratio scale just to fit it in there. And it goes from Luxembourg on the far left to the US on the far right. And on the vertical axis is military spending in billions of dollars. This, I think, was 2017. And the main point is that you can see that the United States is the major contributor to the NATO budget, and the other countries contribute relatively little. The US is like 5% of GDP, and the other countries are some as much as 3% and some as little as 0.5%. And so I thought when I'm coming here, I said, well, I've always been told that Switzerland is armed to the teeth, and that no one would ever mess with Switzerland. So I figured I would put the Swiss budget here. I'm not sure whether this is accurate. There's a problem with what do you do about militias and the National Guard and the police and so on and so forth. But this is what's reported as national defense in the international figures. So I noticed that Switzerland is also looks to be a free rider, and I was thinking, well, of course. I mean, look, you've got all these friendly neighbors. Pacifist Germany, France, so on and so forth. And the only military threat that Switzerland faces is an army of environmental activists invading Davos. And that's as far as you need your army in a modern world. All right? Well, that's a joke, but anyway, it's just like... But it does make the point that Switzerland also looks as if it's obviously benefiting from being in a friendly, relatively Pacific neighborhood. So that's one example, but here's another one which is actually much closer to home, and this is free riding that killed the Kyoto Protocol. The Kyoto Protocol came into effect in 1997, and at the time, in the early 1990s, it would have covered about 60% of emissions, and when it was ratified, about a little over almost 60% of emissions. And then you see what happened. There's this big jump big drop there in 2001, and that was when the U.S. withdrew from the Kyoto Protocol, and that was under the George Bush administration. And what were the penalties to the U.S. from withdrawing? There were none except complaints from allies and environmentalists. And then you go along here, and then the coverage gets smaller and smaller, basically because the coverage was of the high-income countries, and the high-income countries are growing, their emissions are growing slowly relative to India and China and so on. So by the time it expired, and then it expired at the end of 2012. So basically, this shows basically free riding. U.S. pulled out. Then at the end of the period, everybody else just let it expire, and it died. There's only one other thing I like to ask people. You have another event here. Does anyone know what other country pulled out of the Kyoto Protocol? Canada. Let me ask, how many people knew that Canada withdrew from the Kyoto Protocol in 2011? Anybody know that? Okay. It's usually 3. And if I won't ask you, but usually I will say, well, how did you know that? I said, well, I was a negotiator for Canada. But Canada, it didn't even make the newspaper. I didn't even know it until like 5 years later. Somebody said, did you know Canada withdrew? I said, no, I didn't know that. So, but the point, what were the consequences for Canada? Why did it withdraw? Because of the tar sands and the production in Alberta. They knew they weren't going to make their targets. They said, let's just withdraw because there's no point not meeting our target. We just won't have a target anymore. Okay. So the point I'm making here is that the model we have, again, this is all very abstract thinking, carbon prices, carbon taxes, and so on. But this is, how do you do international organizations that are fruitful and effective? And the answer is, it's like a club, but you have to have a club where there are penalties for people who free ride. You can't be in the club if you're a free rider. You can't be in the club unless you participate. And so that's the basic idea that I'd like to suggest in the final section, that we need, as an alternative to voluntary agreements, something I would call a climate club. And it's a way of thinking about how to promote an international agreement that avoids free riding. Okay. So what is a club? I don't have a slide on this, but we all belong, all of us belong to clubs. I mean, if you're a citizen of a country, you're in a club. You basically, there are certain resources that are produced and enjoyed by everybody in the club. They're costly. They're collective goods, so we don't produce them by ourselves, but we enjoy them. And you pay dues. You pay your taxes if you belong to the national club. Or it might be another kind of club. It might be a health club where you pay your dues to be in the health club. There are other international examples. The EU is, I think, the most interesting club that is close to you. If you're in the EU, you have certain dues you have to pay. You have to pay, literally, you have to pay your budget expenses. But you have big benefits as well. You have the benefits of the unified market. You have the benefit, if you of a common currency if you're in the Eurozone. You have many other things. But you have obligations. You have obligations. In fact, you have your climate obligations under the European Treaty. But there are other ones as well. There's NATO that I mentioned earlier. The United States is a big club of states. The European Central Bank, club of central banks. The WTO is in a way the most interesting one, because the WTO is something where you provide benefits to other countries in terms of low tariffs, and reciprocally the countries provide it to you. And I think it will survive. So what might the analogy be here for climate change, for a climate club? First, it has to have a structure that does something to overcome free riding. And here the idea is that club members agree to undertake some costly abatement. I'll talk about what that might be in a second. And if they're not in the club or they don't meet their obligations, then they get penalized. Now, the only realistic penalty that will work in this framework is some kind of trade sanction. And it could be different kinds of trade sanctions. But we know that trade sanctions are effective in many contexts, for example, in the WTO. Now, here's an actual example that I might use that would involve a regime with two features. The first feature would be a minimum domestic carbon price of, say, $50 a ton. You can get there any way you want, but you have to be certified. The certifiers come around and say, yes, Switzerland has a $60 a ton carbon price, and therefore you are a bona fide certified participant in the club. But then there's also penalty tariffs on those who are either non-participants or don't meet their obligations. And there might be something like a countervailing duty, or it might be something just like a simple penalty tariff on imports of non-club members into the club. So the dues, if you think of, again, the club metaphor, the dues you have to pay are the expense of abatement. It's costly. It's not free to do these things, to shut down your carbon-emitting plants. And the penalties for non-participants are the tariffs. Now, there's history. Now, why do I think this is an appropriate approach? First, there's history. Look at the Kyoto Protocol. Look at the Paris Accord. Look at the WTO. Look at the EU. So look at the history of international agreements, which ones have been effective in forcing or inducing countries to take expensive steps. And there are ones that have penalties for non-participants. There's also modeling. Economic modeling is very much the favorite thing of economists to do, but actually they do illustrate this point as well. And just one last example here, we did some modeling at Yale. We call it the coalition dice model, coalition for club or coalition model. And we did just the example I showed in the last slide, which was a $50 a ton carbon price, along with a penalty tariff of 3% on imports. And we found that induced virtually every region to join rather than be faced by the penalty tariff. Okay, so let me wrap up what I've said this afternoon. First, I think it's clear, all the evidence, that the current trajectory we're on for climate change is alarming. You can use different words: terrifying, concerning, terrible, whatever. But it's a grave concern. It's been clear that it's a concern for decades. It was a forecast when it was first suggested 50 years ago, but you see stories in the newspaper every day that gives evidence of the consequences. From an economic point of view, carbon pricing, it could be either, or taxes, is the most effective instrument and approach to slow climate change because it gives incentives to everyone, to you, to me, to our governments, to our firms, to take abatement measures and to innovate. But a review of the landscape here shows that price regimes are highly fragmented and have been quite ineffective. The current model, the Kyoto/Paris model, is a dead end. It will not accomplish what we want because it has no incentives to prevent the free rider of countries. A potential approach would be something like a climate club, which is modeled on other effective international agreements. And the key point about the climate club is that once you're in the club, it's in your interest to take strong abatement measures because of the cost of not being in the club. So just as Greece had to take painful measures in 2010 to stay in the Eurozone and the EU, so countries who are faced with expensive abatement would have to do the same in a club-type region. I think I'll leave it there, and thank you very much for being here.